Hey guys, so we're going to be working on solving for variables in equations that have geometric applications. So this right here should look somewhat familiar. We've got two parallel lines. We know that because of these arrows. And we've got our line of intersection here. And we studied the angle relationships. So we can actually solve for y and x using those angle relationships. Because we know, for example, that this angle right here that I'm underlining, let me switch colors to red, that expression, y plus 25, is expressing the measure of that angle, should be equal to 105, right? Well, we can set about solving for that then. So if y plus 25 equals 105, we should be able to solve for y, because I know that these angles are congruent. So I subtract 25 from both sides, and I end up with y equals 80. Okay, we still need to solve for x though. And by the way, remember we check our equations, right? So I could take that 80, plug it in for the y, make sure it comes out to 105, and it does. So there's a few different ways we could solve for x. And rather than describing all of the different ways I can think of, I'm just going to go with one of them. But I'm going to ask you guys to maybe hit pause and think, are there other ways you can think of to solve for x than what I'm showing you right here? Okay, well, the one thing that I do know is I know that this part right here, 3x minus 5, this angle that's expressing is congruent to this angle because of our angle relationships. I also know, I'll put a question mark here, I also know that question mark is going to be equal to whatever it needs to, or whatever number is going to be supplementary to 105. So if I go 180 minus 105, I should get the question mark. And I get 75. So that means this angle should be 75 degrees, because 75 plus 105 makes 180, and the whole thing here is a straight angle. So now I can take the same similar strategy. 3x minus 15 should equal 75. So if I add 15 to both sides, I get 3x is equal to 90. And then I, of course, divide both sides by 3, and I end up with x being equal to 30. So I've done all this work to come to the conclusion that x must therefore be equal to 30 and y must be equal to 80. Now again, I want you to ask yourself, what are some of the other ways that you could have solved for x then, that don't include necessarily using this angle, this question mark angle that I gave you? All right, be thinking about that. I've got one more example for you. So in this example, it's not two parallel lines, right? But it's just two lines that intersect at a point. But I can still use angle relationships to solve for y and x. So I know, for example, that this right here is a straight angle, right? So I know that the 2y plus 6 plus 3x should be equal to 180. But I've got a little problem here. And that problem is I've got one equation with x and y. And we talked about that in our equation unit, why that kind of gets us stuck, right? That's like a literal equation. We could solve for y, solve for x, but we'd still have a variable. So that's a good relationship. I want to write it down, but it's not going to be my starting point. Let's think about vertical relationships now. I know, for example, that because this is 3x, that this must also be 3x. I know then that because this is 2y plus 6, this must also be 2y plus, oh, wait a second. Huh, that's strange. I thought vertical angles were congruent. Well, they are. And this is our point of entry, okay? Because they're telling us that 2y plus 6 is the same thing as 8y minus 2. We can just set that up as an equation. And now we've got one equation with one type of variable. So I begin by subtracting 6 from both sides. I get 2y, equals 8y minus 108. I subtract 8y from both sides. And I get negative 6y is equal to, let me fix that real quick. Sometimes my pen's not all that responsive. The negative 6y is equal to negative 108. And I can finish that over here if you don't mind, running out of room. So negative 6y is equal to negative 108. You guys know what to do. Divide by negative 6. Not 6, but negative 6. So now y is going to be equal to, whatever that is. So I know a negative divided by a negative is a positive. So I'm just going to forget the negative sign and do the division. So let me do it over here. 108 divided by 6. So I get 1 in there, 4 left. 6 times 8, so 18. So y must be 18 then. Okay, interesting. So if I know that y is 18, I could plug it in and double check I did my math right. So I could plug in here y is 18 just to triple check that I did the equation right, but I don't want to make you bear through me doing that, so I'm just going to say that's what I would do. So now I'm going to take the 18 though, and what would happen if I inserted it right here? Then you might be noticing right away that's going to give me a number here, and then I'm just going to have the x. So that's going to enable me to solve this equation. So let's do that. Let's plug in what we just said y was. And by the way, I just want to address that. If we solve for one y in the diagram, that means every y in this diagram is going to be 18. When we solve for x, every x in the diagram should be 18 because we're working with the same diagram, or same figure here, I should say. Okay, so 2 times, oops, I just wrote 3, but I said 2. So 2 times 18 instead of y plus 6 plus 3x equals 180. So now I've got 36 plus 6 plus 3x equals 180. Combining terms here, and I'll subtract that 42 from both sides. So now I have 3x equals 138. Now I have to divide both sides by 3, as you know. So I'll come up here to do that work. 138 divided by 3. Get 4 of them in there. So 46. So it looks like x is equal to 46. Interesting. So I have correctly now solved or made the statement that y is equal to 18 and x is equal to 46. Wonderful. I've accomplished the task, right? Well, I want to leave you with one question, and perhaps you can come to class with some ideas on this question. In the last example, I asked you if you could think of any other ways to solve for that particular variable. And in this example, I want to ask you, what do these numbers actually mean? I mean, think about it. It's not degrees, because if x was 46 degrees, that would mean that this angle here would be 3 times 46, which is, an obtuse angle, and that angle is not obtuse. And I just think that 18 that's 30. That would make this whole thing 42 if y is 18. So I'm wondering, that just doesn't seem to work, right? Something's wrong. Something's not working right. I know that I've solved for x correctly. I know I've got the right value for y. So I'm wondering if you could think of a reason why this might not work in the same degree sense we're used to. Come to class with some ideas on that. All right, guys. Thanks and good luck.